Hey everyone, my name is Bekker. I'm based in Cape Town. I'm the co-founder CEO of CHARR. We're a DMRV solution and also develop and mobilize biochar projects. Today I'm going to be talking to you about getting digital monitoring, reporting, verification done in the real world and some practical lessons from implementing this in the field. So just as a bit of introduction, CHARR, our kind of MRV solution, stands for Carbon Harmonization and Accounting for Reductions and Removals. We've rolled out various DMRV solutions in the biochar space, including conservation burns, ring of fire, the air curtain burners that foundries operate, and we've also built a ISO 14064 corporate level carbon footprinting software for corporate client. We've got hands-on experience in the field, so I understand practical problems that come up, especially with mobile biochar production. I co-authored the paper with the US Forest Service that was published last year on mobile biochar production. We've done various carbon footprint assessments, life cycle assessments in the agriculture, corporate and product settings, so we understand like what's required when you get to verification and auditing and these kind of things. We've got a good team of other co-founders, is a chemical engineer and an attorney, and we've got software developers and a senior scientist. So something we've always lived by and will always live by is that DMRV becomes a byproduct of a functional system. And really what we mean by this is that we build software, data management, which is DMRV, that serves the business in its entirety and not just building MRV because we want carbon credits. Because ultimately carbon credits is a part of the business that is doing the work, managing fuels, producing biochar, and carbon credits pays for part of it, but it's not the entire business. So then just to set some context, what I'm going to be talking about today with this mobile biochar production methods. So the first one is conservation burn piles. It's basically an improved method of pile burning that yields biochar. So these are distributed across large areas, operated by hand crews, quenched with water at the end. The ring of fire kiln, which is a flame cap kiln, also mobile, can be set up in various configurations and operated by hand crews. And then we've got the beast, the TigerCat 6040. So this is earth foundries, obviously a large scale machine capable of processing large diameter logs, and it's mechanized. So to start off, the challenge and why data collection is hard. So there's obviously the expectations from the carbon markets for high level of detail. There's a demand for accurate, reliable data, and this includes data from sourcing your feedstock throughout your entire process, lab samples, everything till the end use and where your biochar is ending up. And then part of the challenge as well is like a lot of the existing protocols like lend themselves toward industrial scale biochar, which is a different context in terms of like it's centralized, you've got more opportunity to automate and kind of have embedded IoT devices and these kind of things, and it's just not practical for mobile biochar production. Now, the reality in the field with mobile biochar production projects is that field conditions are variable. There's limited time and staff, like teams are busy, things happen, connectivity is an issue. The teams on the field need to get work done, so operations come first, data collection comes second, and this is also part of like the early deployment, which is low habit formation. And basically what this means is that in the initial stages of projects, like the team, the crews, and the data collection person is not necessarily like used to collecting the data, so you make mistakes. But this is also important to like understand like where we're making mistakes, why we're making it, like, is there a better point in time to collect this data? And then mobile biochar production just requires more data by nature and proof points because it's distributed, because it's can happen across large areas with hand crews. And then some common pain points. So defining like a state of measurement, and I'll get a bit more into this, really understanding when to measure. Limited connectivity is obviously a problem, like when you're running operations in the field, I mean, you might have Starlink, but the teams aren't necessarily always close enough to it to use it. Balancing accurate data with like what is practical and keeping actual operations moving. And then tracking numerous small batches, your representative sampling, and the repeatability of your data collection is a bit of a pain point. Now, some lessons from the field. So like I was saying earlier, the measuring at the right point in time is really important. So for example, if we take, how do we get to our dry mass of biochar? We can either get there through weighing our biochar, taking moisture content samples, or we can do volume estimations with bulk density. But there's only specific windows that we can do this. Adapting to context, so really like understanding like there's no one-size-fits-all solution for mobile production. Like you're always going to have to adapt to context. Like one of your projects won't necessarily be the same as the next one. So we need practical solutions for like how do we actually measure and monitor this work. Simplifying sampling. So again, if you've got distributed projects, like how do we simplify sampling and the guidance that the team on the ground needs for how do we sample it, how do we label it, how much do we sample, when do we sample. Staying flexible with logistics. For instance, like we might think we're going to transport all our biochar off-site with super sacks. But what happens if we want to transport biochar on a trailer, or we can't weigh super sacks and kind of move it like that? Like, what does the sampling and measurement protocol become if we're now transporting biochar on trailers and not super sacks? These are all like practical problems that come up when you've maybe got a rigid system with mobile technologies. And then planning roles and timelines for like when you're measuring and like assigning who is doing these measurements. So then some field tested strategies that we've like seen over the last few years that actually works. So again, keeping sampling simple and repeatable, standardized wherever possible. So whether this is measurement devices, scale, like what you're measuring and how you're measuring, calibrating your measurement devices, you know what I mean? So like actually like having data to like show that you've calibrated your devices, validating your measurements are accurate before you commit to it. So this could be moisture content sampling, like what are we using? Are we using like handheld moisture meters, other more advanced moisture meters? Are we using lab samples? And again, like what is repeatable and is it accurate? And then ultimately controlling what you can control, but using statistical data for when you can't control something. So example of this would be, we might have hundreds of trucks driving logs to a log deck. Each truck can't necessarily go over a weigh bridge to get the weight of it. So like, how do we use an average? How many trucks do we have to send over a detour to go over the weigh bridge to actually like get a representative sample to say like, we've done enough sampling to use an average across all the truckloads that have delivered feedstock to like a log deck or to a site. So this is like, it's like real practical problems when you like need this data, but you can't ask the truck driver to go over the weigh bridge for every truckload. Then tracking it right. We've set up the software and kind of how we design projects that we create batch IDs. So this is really useful for tracking like how much we've produced, when and where, linking your lab samples to it, your end use, labeling at every handoff. I mean, like I literally got some lab samples results this morning from a project, and clearly the lab didn't understand what we wrote on it. So even just like labeling accurately is really important, because if you like write poor labels, by the time you get that back from the lab, it might be really difficult to understand like what you actually wrote on it, and like what batch it refers to. And if you don't have batches, like what are you referring to? So when you're going through carbon certifications, like obviously understanding that you're going to be expected to provide source documentation. This would be fuel receipts, obviously lab reports, like anything that's like linked to your carbon certification, your emissions or processing. Something else we've also seen over time that works well is like if you can develop some sort of baseline unit calculations. This could be how much feedstock are we processing, or ring fencing a certain amount of feedstock, measuring how much biochar comes out of it, and then actually using that to sense check yourself later. So if we know whatever amount of feedstock produced this amount of biochar, can we then at the end of the project sense check a biochar volume to how much feedstock we assumed came in or calculated came in with truckloads. And also really important is just like literally logging your notes before you forget, and not thinking you're going to remember it later, and then you don't know what you wanted to document. So then making it work in the field, so integrating data into like low motion or like low friction points. So not stopping your operations to collect data, but like actually working into like natural pauses of like when the team is able to collect this data. Offline first, super important. So kind of assuming that you're always going to be offline, that means that when you're in Signal, you have to sync data from the cloud onto your mobile device, and then vice versa. When you get back into Signal, that you sync your data so it appears on your cloud and your web app, for instance. Obviously, assigning data supervisors and a data lead. This helps for accountability, making sure data is accurate, complete. We obviously want to automate everything and digitize everything, but at the end of the day, there's still a client sitting on the other side who might want to talk to you about, like, did we do this right? Do we have everything? So keeping a human feedback loop is also really important to making it work. Collecting data once and using it many times, it also helps with kind of reducing the amount of data we need to collect across projects. So for instance, if we have standardized data frameworks per project, that we can pull different parts of the data to flow into projects. We don't have to define it for each project. And also just aligning your export data with whether that's for client export, for your carbon certification, for sales, whatever you need. And then some takeaways. Sorry, I see my slides got a bit jumbled up. So takeaways, so with all of this now, like, what is good enough then? So industrial biochar, that's kind of our near perfect place to be, where we might have industrial data loggers, we can put in sensors, IoT devices. It's just impractical for mobile biochar production. So what is good enough? So good enough then basically means we need accurate, conservative, and replicable data. And our rule for this is usually repeatable data is better than heroic once-off data points that might be really accurate, but you can't do it consistently. Designing for single state, for state, timing, and single point data opportunities. So if you think about like the ring of fire kiln, if we're doing bulk density and volume estimations, by the time we've put water on this, like, you can't do a bulk density and volume estimation anymore. So what then? Then you would have to weigh your biochar and take moisture content samples. But how do you weigh it? So there are certain like data opportunities that, like, if you miss it, it's gone. And then the next step to like get that data out is really complicated. So again, embedding MRV in your natural workflows, defining what is good enough, why it's good enough, and like actually documenting that and applying that consistently, especially when it gets to like a verification auditing point, that you've got consistent data with evidence of why you chose that point. And ultimately, like I was saying, like, the goal of this is really to develop MRV, which is just a data management solution for a business to use as in the entirety of their business, and have the MRV component for your carbon certification just flow out of that for byproduct. Being able to use that same data set to report to a funder, to a client, to your own internal reporting, to be able to like understand what's happening in your operations. Why is one project producing more, yielding more? So yeah, that is me. Thank you.